because you'll need to use it. All right, so we just did our activity, our little warm-up exploration, and now our objective for today. Actually, to be very honest with you, this objective that you copied down in your notes is the objective for all of section 7.4, and this is going to be a 3-day section. So for today, the big idea is just writing exponential equations as logarithms. That is what we are doing. Essentially, we're going to be able to use that information to evaluate some logarithms today, so that's kind of a fun thing. And then I'm going to show you how you can use your calculator to calculate some logarithms, but not all. So I'll show you how to use your calculator a little bit today. We're going to use that log button and that ln button that we were talking about the other day. Initially, we should start off our notes today by talking about the definition of a logarithm. What you may have noticed as you went through the activity today is that your base and then the number next to the log were always positive numbers. That is always going to be a true story. And then the base can't be 1, and that makes sense, because try to make 1 a base in an exponential equation. Let's say you want 1 raised to some power equals 16. You can't have that. So your base is never going to be 1. The logarithm of y with base b is denoted by log base b of y. And here's where its definition comes from. So we say that log base b of y equals x if and only if b raised to the x power equals y. Now that activity you did as your warm-up today came from your textbook editor, and this definition comes from your textbook editor, but it wouldn't be my lesson if I didn't give you my spin on things. No pun intended. Actually, that is totally a pun. I teach this. You know, if you went through the activity today and you're like, oh man, I'm never going to remember which number is the base for the logarithm, which number is next to the equal sign, I am going to mess that up. This is for you. Okay. I teach this as a little bit like the log cycle. If you need to take something that's in logarithmic form and write it in exponential form, here's a little trick. I call it the log cycle. We could say b raised to the x power gives you y. It's kind of like you draw a circle on your paper. You start with the base, raise it to the power of x, and it'll spit out y. So that gives you this exponential equation right here. And then this last little sentence in our definition today is just how you read a logarithmic equation. We say log base b of y equals, you know, in this case, it would be equal to x. All right. So here's my, for instance, for a log cycle. You just spent some time noticing how exponential equations can be written as logarithms. Well, here's how you could go backwards in that process. You could take logarithms and write them as exponentials as well. We say 2 to the 5th power equals 32. It's a little log cycle for you. Or you could say 7 raised to the power of nothing gives you 1. Or 13 to the 1st power gives you 13. Lastly, 1/2, use your upstairs downstairs rule on it, raise it to the negative 1st power, you would get 2. Now, please keep in mind, you are trying to generate a true statement. If you mess it up, in other words, you're going to know it, because it's not going to generate a true statement. Take, for instance, maybe this first example here. You can't say 2 to the 32nd equals 5. You can't say 32 to the 5th equals 2. So if you write it incorrectly, chances are you're going to recognize it. So that's a little tip for you. All right. Next thing I need to do is show you the usefulness of logarithms. Now, I did get the question. I've gotten a couple times today. How do you do this on a calculator? You don't. Not right now, anyways. So I have to show you how to get log base 3 of 81 without a calculator. Now, when I am asked to evaluate something, what I think about here is like, I'm supposed to answer this. I'm supposed to find the value here, right? So I could put a question mark there. You know, if you want to be very literal about things, you could put an X there. And what we're actually answering today in class is when we evaluate a logarithm, we're kind of trying to think about 3 raised to what power gives you 81? So you got to do a little mental math, or, here you could use your calculator if you want it to help you guess and check a little bit. But you're asking yourself 3 raised to what power gives you 81? Well, what's that value? 4, very good. So the answer to this problem, you could say x equals 4. In part B, if I follow the same sort of logic, do my log cycle a little bit, what I'm trying to think about here is 4 raised to what power would give me 0.25. And when I see 0.25, I'll be very honest with you, I think of 1/4. So 4 raised to what power would turn that into 1/4? I noticed the 4 moved to the downstairs in the fraction. I think, well, yeah, it is, -1. That would allow me to use my upstairs downstairs rule, 4 to the negative first power. You could throw that in your calculator to help you check. You would get 0.25. All right, C and D, I want you to try those on your own. Okay, so I'm going to pause here for a second. So walk around, kind of got those right. Just going to show you, make it official, put it on the smart board. Your answer to part C was -4. Chances are when you use the log cycle to rewrite that problem a little bit, you wrote it as 1/4 raised to what power gives you 256. Well, when I thought about 256, I thought about that as 4 to the 4th. But I had 1/4 as my base, so I had to make the exponent then negative to be able to use my upstairs downstairs rule, yes. So part C, your answer for that is -4. Part D, square root of 49 is totally 7. If we want to use a square root as an exponent, it's the same as raising something to the 1/2 power. So the power in this case, the exponent in this problem is actually 1/2. Are there questions about that? So we did take a little bit of time to talk about our definitions already. You already defined for me your common logarithm and your natural logarithm. Just a reminder, your common logarithm, it's so common, sometimes we don't even write the base next to it. It's just log. That's it. So if you see just log in the problem and you're like going through your bookwork tonight and you're like, it's just log, there's no base. Well, you can assume that that is base 10. Okay. Likewise, we just spent a good amount of time talking about the natural base, or E. So we have a logarithm for the natural base as well. That's called the natural logarithm. It goes with the natural base. So in this case, what you'll see here is, we have log base E, but we never, ever really write it that way. That is the ln button on your calculator. That's log base 2.72, because we use that. We're going to have to solve those PERT equations for time. How much time does that money sit in your account after a while to get you a certain amount of money? Well, we're going to have to use the natural base to figure that out. Or the natural base logarithm, I should say, to figure that out. So I wanted you to get a little bit familiar with your calculator at this point in time. In example 3, you're asked to do log 8. So you grab your calculator. This is on page 10 in the packet. You press the log button. It's right below your x squared, right next to your 7. Log 8 is 0.9. And you're probably asking yourself, what did my calculator just find? So I wanted to give you a little insight into that. When you ask your calculator to evaluate log 8, what you're actually asking your calculator to do, and why we get some crazy decimals, is we're having our calculator answer this question. 10 raised to what power gives you 8? Well, think about that for a second. Looking at x, it can't even be 1. Because if you raise 10 to the first power, your output is 10. So we know that it had to be a number smaller than 1. And because 8 is a little smaller than 10, x is a little smaller than 1. So when we threw that number into our calculator just now, We did get 0.90. I usually round to 2 decimal places for our value there. We also have this sort of set up for the natural log. We could have our calculator evaluate the natural log of 0.3. Now that's the ln button. But before I have my calculator do it, I got to think about what am I asking my calculator to find here. And, whoa, sorry. That happens every once in a while. If I were trying to think about this as a log, what I'm actually finding is log base e of 0.3 equals x. Doing my log cycle on this, I would totally need a calculator. You're asking your calculator to figure out e raised to what power would give you 0.3. Or that irrational number 2.72 blah, 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 raised to what power gives you 0.3. So you would definitely need a calculator for that. I don't even know what it is, honestly. So natural log is right next to the 4 button. That is log base e. And you're probably saying, if it's natural log, why is it ln, not nl? And it's just because it comes from France. It's like logarithm natural or something like that. So it's backwards. So ln of 0.3. Press enter. Yeah, you do get negative 1.2. This also makes sense when you look at our slideshow for today. We had to take 2.72 and shrink it down to be a fraction or a decimal, which means we had to use the upstairs downstairs rule on e. This is the same as doing e to the negative 1.2 or 1 over e to the 1.2 power. We are almost done. I need to bring home one more very important point. And you do have bookwork tonight. Back to the definition, back to where we started. You'll notice that I'll be talking about more of this next week. On the left side of the equal sign, please notice you never have any negative numbers. I'd like you to pay attention to that as you work through your bookwork tonight. We'll talk more about that next week. Hey, have a nice weekend.